So I'm going to discuss the lac operon. The lac operon is an inducible operon, which means that in order to be activated, it has to be induced by an inducer, which in this case is allolactose, but I'll discuss that later. So basically what the lac operon does is it can control the transcription of enzymes that digest, break down, and they digest and break down lactose in the cell. So the lac operon is composed of the promoter, operator, the gene LAC-Z, the gene LAC-Y, and the gene LAC-A. The regulatory gene is not considered to be part of the composition of the lac operon. All the regulatory gene does is it codes for this repressor enzyme. And when the repressor enzyme is in an inactive state, it is bonded to the operator. And when the repressor enzyme is bonded to the operator, RNA polymerase cannot transcribe these genes. So what happens is lactose will come into the system, it will come into the cell, and it's considered a allosteric regulator, which means that some of it is converted into an inducer, and in this case the inducer is allolactose. And what it does is that inducer then goes and activates a repressor, or it inactivates it depending on if it's positive or negative repressor. But anyway, so lactose is going to come in and it's going to attach to the repressor, and now the repressor is going to be active. So the repressor is going to leave the operon, which allows RNA polymerase to go along and transcribe these genes into mRNA. So it goes along and now it transcribes the gene to mRNA. And these genes code for different proteins, which then code for different enzymes. So LAC-Z codes for the enzyme galactosidase. And what galactosidase does is break down lactose into glucose and galactose. The LAC-Y gene will code the proteins to make permease, which transports the lactose into the cell. And then the LAC-A gene, it codes for a transetylase, but no one really knows what transetylase does, what its function or what its purpose is for. So that's it.